All right, welcome to another episode on Prime Logic. This is another viral problem of the day. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So the question says, what is the area of this square that is inscribed inside this right triangle? So what is the area of the square? We have the side length of the triangle is 12. This side length is 20. So what is the area of this square? So let's just name the side of this square as A. We know that the area of a square equals the side squared. So in other words, A squared. So if we can find the value of A, then we can calculate the area. So let's just focus now on these two triangles that are also right triangles because this is a square. So let's just focus on these two triangles. So for example, this angle, if we name this angle as alpha and this right triangle, and the right side triangle, because these lines are parallel, this angle is also alpha. So just for example, imagine these are two parallel lines. So this angle is alpha, this angle is alpha. Let's just name this angle as beta. So this angle is beta as well because the sum of those angles must be 90 degrees. So we can say that these two triangles are similar triangles because of angle-angle theorem. So two angles are the same, these triangles are similar. We can just compare the sides because the sides have the similar scaling factors, corresponding sides obviously. Now let's focus on the sides of the triangle and then calculate them, write them in terms of A. So the whole side of right triangle is 12. It means that this little side here, it is 12 minus A. A is the side of a square, right? So this side is 12 minus A. We can do the same thing for this side of triangle. The whole thing is 20. If we remove the A part, so this is 20 minus A. Okay, so now let's write down these proportions. For example, in this triangle, this upper triangle, we can say, for example, 12 minus A over A, so let's compare this side with this side, 12 minus A over A, the corresponding comparison or fraction in this triangle would be this side over this side. In other words, it equals A over 20 minus A. Okay, so let's just cross multiply and find the value of A. So we can say A squared, so A times A equals A squared. 20 minus A times 12 minus A. Let's just expand this fractions and let's just write it here. So A squared equals 12 times 20 times 12, that's 240. Okay, so this part and then these two terms minus 20A and then this one with this one minus 12A and then minus A, that's plus A squared. So we have 1A squared here with the same sign here, 1A squared, they cancel each other out. So the rest is easy. So 24. So these two terms, they are A, so we can just add them together. Minus 20 minus 12, that's minus 32A equals 0. In other words, 32A, so I just bring it to this side, equals 240. So in other words, A equals 240 over 32, and if we simplify or reduce this fraction, it is 15 over 2. So A equals 15 over 2. So the side of This square is 15 over 2. And then if we do the calculation for a squared, which is the area of this square. So 15a equals 15 over 2 squared, which is 225 over 4. So that's the final answer. That's the area of this square, 225 over 4, or in other words, 56.25. That's the final answer, 56.25, or 225 over 4. That's the area of this square that is trapped here inside this right triangle. So make sure to drop your thoughts and answers in the comments below, and also share your other methods and approaches also in the comments. We always learn from your insights and intuitions. I'm sure there is a ton of other ways to approach this one. So please like the video to support me, and subscribe to the channel if you haven't already, and see you on our next video on prime logic.